Welcome to the physics class. In this video, we are going to start a new unit called projectile motion. So, motion of a particle under constant acceleration is either a straight line or parabolic. So, it can be a straight line or parabolic. So, in straight line, the following three cases are there. First case is u equals to 0, initial velocity is equal to 0, and we are just dropping a ball from the air towards the ground. So it is the under the acceleration g. Just let me open my tab here. Yeah. So initial velocity of particle is 0 here. Then the second case is initial velocity of the particle is in direction of constant acceleration. So we have initial velocity u, there is some initial velocity u given here, and it is in direction of the constant acceleration g. Then we have third case, that is initial velocity of the particle is in the opposite direction of constant acceleration. So suppose we are dribbling a basketball, then the basketball, when it is going from the ground towards our hand, then that's the third case here. This is the third case. Now in other cases, when the velocity is at some angle, then we have a projectile motion like this. We have a projectile motion like this going at some theta angle and with the initial velocity u under constant gravitational constant. Now projectile motions can be of various cases. The very first one is shown here. Second is shown here, that is its horizontal velocity is given there. Then a velocity is given from mid height at some theta angle. So this is a theta angle. Now fourth is downward. In this case, the theta is here. The theta is here. Now fifth case, the plane is inclined. So this is the plane. This one is the plane. It is inclined and we are throwing a projectile at an angle theta. And the opposite direction, the same case but the projectile thrown from this side. This one side is the sixth case. Now we have two methods of solving projectile motion. The method one is what I am going to explain in this video. So projectile motion is 2D motion with constant acceleration. So we can use the equation v is equal to u plus at and s is equal to ut plus half at square. Now we have u is equal to u cos alpha. This is shown here, and just switch on to the laser marker here. So u is shown here. We have an angle alpha here and an angle and acceleration of gravity through g here. So we have u is equal to u cos alpha I cap plus u sin alpha j cap, and we can apply v equal to u, and acceleration we have given a equal to minus g j cap. Now v is equal to u plus at, so u value I have written here and at value I have written here. Then we can take I cap separately here and j cap, the term under j cap is this u sin alpha minus gt j cap. Similarly, for displacement we have s is equals to ut plus half at square, and u value we have given here, and half at square value it is given here. Now we can take I cap and j cap value separately, ut plus ut sin alpha minus half gt square j cap, that becomes our j cap. So that is how we find the position. So this is finding the position. So we can find the position 1, and 2 we can find the velocity of the particle at any instant t. We can find the velocity of the particle at any instant t. So there is a homework problem for you all today. That is, a particle is projected with velocity 50 meters per second at 37 degrees with horizontal. Find the velocity, displacement and coordinates of the particle with respect to starting point after 2 seconds. We are given sin 37 is equals to 0.6 and sin 37 cos 37 degrees is equals to 0.8. So that was all for today. Thank you for watching. If you have gained some knowledge from this video, please do give a like to this video. Thank you.